In this section, we're going to use our definition for the 6 trigonometric functions to work some problems. Here's our first one. It says, find the 6 trigonometric functions of theta if the point negative 5, 12 is on the terminal side of theta. So let's draw a little picture here, first of all, so we can see what theta looks like. So I'll draw in a coordinate system. The point negative 5, 12 is on the terminal side of theta. So let's just say that's negative 5, x equal negative 5, y is equal to 12. Let's just say that theta looks like this in standard position. Initial side along the positive x-axis, vertex at the origin, terminal side right here. So this is our angle theta that we're looking for the 6 trigonometric functions of, and this point right here is the point x equal negative 5, y equal 12. So the first thing I need to find is the distance from the origin out to that point. That's r. R is equal to the square root of x squared plus y squared. So square root of 25 plus 12 squared is 144. That's going to be the square root of 169, which is 13. So that distance from the origin out to that point is 13. I have x equal negative 5, y is equal to 12, and r is equal to 13. I need those 3 numbers in order to find the 6 trigonometric functions of theta. So first of all, sine theta, by definition, is y divided by r, and I know that y is equal to 12 and r is equal to 13. So sine theta is 12/13. Cosine theta, by definition, and we have to have memorized this, is x over r. X is equal to negative 5, r is equal to 13, so I have negative 5/13. Then tangent theta is equal to y divided by x, so that's going to be 12 divided by negative 5, which is negative 12/5. So my first 3 trigonometric functions, sine, cosine, and tangent, I write down because I know the definition for sine is that it's the ratio of y to r, cosine is x over r, and tangent is y over x. So I have to have memorized those 3 ratios in order to find these things right here. Now let's find secant, cosecant, and cotangent. So I'll say my cosecant of theta, by definition, is r divided by y, and so that's going to be 13 divided by 12. And you can see that that's the reciprocal of sine theta. Secant theta is going to be r divided by x, and that's going to be 13 divided by negative 5, so negative 13/5. And then cotangent theta, by definition, is x over y, and so that's going to be negative 5 divided by 12, negative 5/12. So here's my 6 trigonometric functions using the definition that gives me each of them as the ratio of 2 of these 3 numbers, x, y, and r. Sine is y over r, cosine x over r, tangent y over x, and then cosecant, secant, and cotangent defined this way gives us this result. Let's look at another problem. Let's find sine, cosine, and tangent of negative 45 degrees. So first of all, I'm going to draw negative 45 degrees in standard position. It's my x-axis and my y-axis. In standard position, negative 45 degrees is going to be down here. So that's negative 45 degrees. Because when I measure my angles, if I measure in a clockwise direction from the positive x-axis right here, that gives me a negative measure for angles. If I measure in a counterclockwise direction, that's a positive measure. Now, because of the definition, the only way I can find sine, cosine, and tangent of this angle right here is to find some point on the terminal side. So I'll make this real easy on myself, and the point that I'll use on the terminal side is x equal 1, y equal negative 1. Because I know negative 45 degrees splits that quadrant, the point 1, negative 1 must be on the terminal side. So if x is 1 and y is negative 1, r is going to be square root of 1 squared, which is 1, plus negative 1 squared. That square is also 1, and so I get square root 2. So now I can find sine, cosine, and tangent of negative 45 degrees. Sine negative 45 degrees, by definition is the y-coordinate divided by r. So it's going to be negative 1 divided by square root 2. So negative 1 over square root 2. Cosine of negative 45 degrees is going to be x divided by r, which will be 1 over square root 2. And then tangent negative 45 degrees will be y divided by x. And again, I have these ratios memorized, and that's going to be negative 1 divided by 1, which is negative 1. So sine, cosine, and tangent of negative 45 degrees, I have to draw it in standard position, find a point on the terminal side, find the distance out to that point, and then I have to have memorized these definitions right here for sine, cosine, and tangent. So there isn't any more to it than that, but you do have to memorize those definitions. Here's our last problem. If tangent theta is equal to 3/4 and theta belongs to quadrant 1, find sine theta and cosine theta. Well, if tangent theta is 3/4, I know by definition that that's the ratio of y to x. So I can say, if I want, let's let y be equal to 3 and x be equal to 4, and then I'll have two numbers whose ratio y to x is going to be 3 to 4. Now, just because the ratio of y to x turns out to be 3/4 doesn't mean always that y is 3 and x is 4, but I can at least let y be 3 and x be equal to 4 and get two numbers whose ratio is 3/4, and that's all I need. Now, let's find r. R is equal to square root of x squared plus y squared. Square root of x squared, which is 16, plus y squared, which is 9. I just said it in the wrong order. Square root 25, or I should say positive square root of 25, which is 5. So sine of theta is going to be y divided by r. Y is equal to 3, r is equal to 5, so that comes out 3/5. And again, I've memorized that ratio. Cosine of theta is going to be x divided by r. I've memorized that ratio, and in this case I've said x is 4, r comes out to be 5, so that's going to be 4/5. So if tangent theta is 3/4 and theta terminates in quadrant 1, meaning sine, cosine, and tangent will all be positive, then sine theta must be 3/5 and cosine theta must be 4/5. So if there's one thing that you want to have done after you finish this section, it is you want to have that definition for the 6 trigonometric functions memorized.